Okay, so in this vodcast, we are going to be talking about scientific notation. Now, that's just a fancy way of saying that we're making a number a lot simpler. So in science, you'll notice that we use a lot of really, really big numbers or really, really small numbers. So for example, the distance from the sun to Pluto is 5,906,376,272 kilometers. Now that's a huge and ugly number that we don't want to use, and so in science we have a much simpler way of writing it, and that's 5.9 times 10 to the ninth power. So basically what we did was we took out all of these numbers, we disregard these numbers, and we're just taking into account the most important numbers here, which is that we're saying that it's 5.9 billion kilometers from the sun. So this number right here is what we call a coefficient, and that's the number that signifies 5.9 billion. And then right here it says times 10 to the ninth power. Now this is called a raised power 10 to the raised power of 9, or exponent of 9. And you'll see why in our next example. Basically what we're doing is we're saying that 5.9 times 10 is approximately this number. If we're not talking about 5.9 times 10 to the ninth power is approximately this number. So here's another example. The cells in the human body, 37,200,000,000,000 cells are approximately estimated in the human body. So here's an easier way of writing it. First, I'm going to put a decimal right here, then I'll explain why in a minute, and then I'm going to count how many places from the decimal to the end of the number. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So here's how I'm going to write this number. The decimal was originally here. I'm moving it all the way over here to 3.7. And so here's how I'm going to write this. I'm going to write it like 3.7 once I end up writing it. 3.7 times 10. We counted 13, so 13 times 10 to the 13th power. Now what's important to know about this 3.7 is that this number always has to be between 1 and 10. So I'm jotting that down right here so we can see that this number always has to be between 1 and 10. That's why I decided to put the decimal right here. If I were to put it after 37, that's greater than 10. Can't use that. If I were to put the decimal before the 3, that's less than 1. So it has to always be between 1 and 10. And then the number of digits here is how many goes in the exponents. So here's another example. The width of a human hair is 0.00007 meters. So I'm going to be writing this a little differently than the previous number. I'm going to take that decimal, move it 1, 2, 3, 4, 5 spaces. So I've got a number that's between 1 and 10. That's 7 times 10 to the negative 5th power. Now you'll notice that I've got this negative sign right here, and that negative sign is telling us that it's a really small number. Whereas up here, we're talking about a really big number. That's why we have a positive 13. Right here, this means a really small number. So a rule of thumb to remember is that wherever you see a negative exponent in scientific notation, that means we're talking about a really small number. So that means the decimal is way over here instead of way over here. So wherever you see a positive exponent, that means it is a really large number. Alright, so try a couple practice problems and come back to this video if you find yourself confused.